So it's good to see you all over again. I'm Natasha and welcome back. So today we're gonna continue our chapter 4, mathematical induction. And in the previous video, we discussed about mathematical induction, and in today's video we're gonna do a question. And so I've already written the question, and yeah, one more thing is that this question is just related to the last example that I took in the previous video, which I just told you, and I even told you in the previous video too that I'll be like taking that same statement as a question. So here I've just written that question. So what are we waiting for? Let's get started. Okay. So I've written the question. It's saying prove the statement using the principle of mathematical. Oh, wait a second. It's actually here E will come. Yeah. Prove the statement using the principle of mathematical induction for all n belongs to n. Okay. So n is actually these n's, okay, and this capital N, which is for the set of natural numbers, okay. So it's saying just we have to prove it. So we're gonna use it, and yeah, it has also said us to use the mathematical induction. So let's use it. Okay. So first step, as we all know in the mathematical induction, is the base step, in which we just find just prove that the statement is true for the initial value. Okay, so we're going to take a small base value. So solution, first step is our base step. So I'll be like just writing in, so I'll just say we have to prove. So let's say P, okay. So P of 1, as 1 we have the smallest value here, okay. So P of 1, I can say P is actually for the proving, like we're proving it. So P1 is equal to, okay. So first of all, let's just leave this thing. Okay, one thing we have to just focus on is on the left hand side. We have to focus on the left hand side and its right hand side. So what's the left hand side? So the left hand side is like 1 cube plus 2 cube plus 3 cube till n cube, okay? So we're not going to write all these things. So we're just going to look at the value. The only value we're having right now is for 1. So what I'll say that the left hand side, the LHS, is 1, okay? And about the RHS, what is it? We can see at the place of n, we have said that n is equal to 1. Okay, so at the place of n, we're gonna put 1. So it's gonna be 1, and in the bracket 1 plus 1 upon 2 square. Okay, so which is going to be 1 plus 1 2, and 1 into 2 upon 2. So it's gonna be 1. Okay, so overall it's gonna be 1, and as you know, it's going to be 2 and 2 upon 2, which will be just 1, okay? And 1 square will be, of course, 1. So, I didn't just mention it. So, I just directly wrote the answer, okay? So, it's going to be like this way. So, as we can see, the left-hand side and the right-hand side is equal. So, LHS is equal to RHS, okay? So, what we can see is the P of 1, for the value of P of 1, it is true, okay? So, what I'll say is LHS is equal to RHS. Okay? Okay, this is clear. Now, the next thing we're going to look for is the P of K. So let's take a fixed value in which, the value which I'm going to say is going to be K. Okay, so I'm going to say that n is equal to K. Yeah, it's actually, now next comes the induction hypothesis, okay? So in which we're going to actually just, take a value for n. So we're going to take the value for n, let's take K, okay? So n is equal to K. One thing's already fixed, so at the place of 1, I'll say this, that P of k. So we're assuming that P of k is true. So then we have to prove that P of k plus 1, P of k plus 1 should be also true. Okay, so first of all, let's just have a look at the statement, like according to this thing, like how are going to be our statement. So how's it like, or how we will write it. Okay, so let's just have a look at the second one. Okay, so what I'm going to say is actually we're assuming it, so it's actually not true. We're just assuming it. So I'm going to say let P of k be true, okay? Let P of k be true. Then it's going to be 1q plus 2q plus 3q plus ... till nq. So nq will be kq. kq is equal to k of k plus 1 upon 2 square. Okay, so this is what we're going to get, isn't it? Now we have to prove that P of k plus 1 is true. Okay, so that's what we have to prove. Okay, so what we have to do is we have to show that P of k plus 1 is true. Okay, just have a look. Got it? So we're gonna just prove it by just the given statement. Okay, so by this statement. Got it? Okay, so but before continuing on this topic, so I'm just gonna check the camera, like is it clear or not? So of course it's clear, so let's move on. Yeah, so we have to show that P of k plus 1 is true. So for the k plus 1, our statement's gonna be a little different than this one. So what is it going to be? I'm just going to write this. So it's going to be 1q plus 2q plus 3q plus ... till plus k plus 1 again q. Okay, yeah, and then we're going to write k plus 1, then k plus 2 upon 2 whole square. Okay, yeah, like right here I just added 1 and 1, so from which I got 2, and oh wait a second, I think it's all right. I think I'm just gonna use the square brackets. That's what I was about to do. Okay, so it's gonna be k plus 1 in the bracket k plus 2 upon 2 square. Now this is right. Got it? So we're gonna just have a look at the LHS and the RHS. That's it, nothing else. So this is how we'll see that if P of n, what exactly we're doing is actually we're proving that this n is true for all the natural numbers. Okay, so they all belongs to the natural numbers. That's it. So let's have a look at the LHS. What's our LHS? So our LHS is k plus 1 cube. Okay, so we're just gonna have a look at this thing. Okay, as we're just talking about that thing. So and including this, we're gonna write only this thing. Okay, so it's this k plus 1 in the bracket k plus 2 upon 2 square plus k plus 1 cube. Just have a look. Okay, this is going to be just like this way, and the next step that I'm going to just have let me write it right here. Okay, so I'm just going to write here. So this is going to be for the k plus 1, k plus 2. Okay, so it's overall I can just exactly see it's just coming in a simpler way. So what I'm going to suggest is equal to k plus 1 square. So one of the k plus 1, I just move it there, and what I got was this. Wait a second. Yeah. In this case, we don't need any square bracket right now. I'll just look at it. K squared upon 4 and 2 plus 1. Oh, no, it's not going to be 2 plus 1 actually. What do we have is k. So 2 will not come. Actually, we're going to write the k as we have the value k given. Got it? Okay. Good. K plus 1, okay? And now this is going to be in bracket. So just have a look. Is it clear? Okay? So what we have is our k plus 1 squared plus k squared plus 4 plus k plus 1, so which is in bracket. And this whole thing, like I'll be just solving it right now. So this k plus 1 squared will be as it is same. K plus 1 squared plus and now as we can see, like the 4 here. So this 4 will be, we'll just shift it, so according to this, like we'll have this kind of sum, okay? Wait a second. Okay, so first we need to understand this. Got it? So what I'm going to do is I'm going to merge them all. So, the numerator, the whole numerator, got it? Okay, and then denominator will stay same for all, for all these two. So it's going to be k plus 4k plus 1. Okay, plus 4. Just have a look. What I did was really easy. Was definitely easy. Okay? Yeah. So at the place of 1, which I'm just going to write by, just the multiplication with it. So it's also going to be 4 ones of 4. Of course, we're going to get 4. So not the 1. At this place, we're going to get 4. So is this also going to get changed? Like just, to make sure, like this, is this also going to get changed k squared? No, absolutely not. It's just going to be, it will be just stay same as it is, okay? Okay, so now it has become really easy for us. So now it's going to be k plus 1 squared. I'm going to write as it is. And in the bracket, I'm going to write k plus 2 upon 2. Oh, wait a second. I'm going to write this again. It was, just becoming a little messy, a little dirty, whatever. Yeah, so we have k plus 1 squared as it is. I'm just going to write it. So, which I'm going to get k upon 2 in the square brackets and square. Okay, just have a look at this one. Is it clear? If this is clear, then everything will be clear. And by just this way, what are we going to get? We're actually going to get the same thing. We're actually going to get the same thing. Got it? Okay, so which I can see is k plus 1, which we'll also put in bracket. There's like no difference. So for this, we're just going to get the same. What I did, I just added them. But, just in a simple way. So it's going to be k plus 1, then k plus 2. Not in the way that like really adding them, but what I did was that I really merged them. So this is going to be the final result. Just have a look. Okay. So what I did was, maybe you'll be a little confused from this step, but there's nothing to get confused. So in this step, like we had the k plus 1 and k plus 2. But yeah, remember one thing, this is our RHS as we can see. And this was our LHS, so don't forget, okay? So according to our LHS, what I did was the 1 of the k plus 1, I just, moved in there. So through this way, the 2 in the denominator I got. So this is how through the way I got k squared upon 4 plus k plus 1, which I just, it's actually this k plus 1, got it? And then after, for the 4k, 4 to the k, 4k, 4 to the k, 4k, and 4 ones are 4. That's what I did. And the k squared, was as it is same upon 4 the denominator. And through this way, again the k plus 1 squared as it is same. And then k squared plus 4k plus 4. So the 4 to 4. Yeah. So the 4 to 4 was, in this way, like, remember this is a square, which means that we got this, we got this thing as it is twice, okay? So which means that it was actually like this way, k plus 2 upon 2, then k plus 2 upon 2. So it was just like this way, okay? That's what I did. That's what I did. So it's what I did was the 4k I had right here. And the k squared, so what I did was k and k with k. And this 4, I just, divided. So it through this way, like I got the 2 and 2. Like 2 2s are 4, isn't it? And so that's what I did. And for the 4, which it is just right here, I did the same with all these things. So, it's really easy to understand, but, I think there wouldn't have been any need. So there wasn't actually, for me, like there's no need to, to discuss about these small things. These are just really the small things for which like we don't have to waste our time on it. Okay, so we're like not wasting our time on this. So let's just forget about it. That was really easy. If we're just going to have a look at this once, we'll understand it clearly. That's what we'll see. So as you can see in the left, what do we get? That the LHS is equal to RHS. So the left hand side is equal to the right hand side, which means, therefore, P of n is true for all n belongs to the set of natural numbers. Isn't it? As we can see, the LHS is just, what was our LHS? So first of all, like, having a look at this one, we got our LHS just right equal to, from the LHS. So that's what I wanted to see. If P of k true, P of k, we said that let's say that P of k is true, and what was our what was our right hand side? It was k to k plus 1, but let's just forget about it. But about the P of k plus 1, we got the right hand side this. So what I did was I proved this same thing just right here. That's what I did. And through this way, we got this, that P of n is true. That's it. And I hope like each and every step just clear. What I did was really easy. Okay? Okay, so that's it. And I think like only one question is just enough. Oh, wait a second. Yeah. So, that's all for today. And in the next video, we're also going to, So, sorry for that. So in the next video, we're gonna, do another question. So we're gonna discuss a small question, and then after that, we'll maybe discuss about some new topic, any new topic. So, thanks for watching and have a great day.